Hey friends, we're in chapter 3 and we're looking at operations on rational numbers, and we're going to be adding and subtracting like numbers. I think we could probably actually call this section adding and subtracting like fractions, because that's really what we're working on. All right, so first question is, what on earth are like fractions? And basically like fractions are fractions that have the same denominator. So for instance, we could have 3/4 and -2 1/4. The fact that these are fractions, right, and they have the same denominator makes them like fractions. It doesn't matter that this is a whole number, that this is a mixed number and this is negative. Doesn't matter. We're going to consider these like fractions, so it's going to be pretty simple for us to deal with them. 1/8 and 7/8. Once again, we just want to have common denominator, same denominator, all right? Okay, let's take a look at example 1. Add the following fraction. So let's take a look. So here are the problems. We've got common denominators. When our denominators are the same, we just add the numerators and bring the denominator along for the ride. So I'm going to leave a 10 down here, and my numerator is going to be, let's put it 7 plus 6 just to maintain that order. 7 plus 6. And what that leaves me with is 13 over 10. Like I said in a couple other videos, I kind of dig improper fractions, but if you're asked to make this a mixed number, of course you're going to divide 10 into 13, which goes one whole time with a remainder of 3 over 10, the divisor. Make sense? Let's take a look at this next one. This one looks a little bit more interesting. I've got 5/8 plus a -7 over 8. 8 is the denominator. I'm going to keep it just the same, and my numerator is going to be 5 plus a -7. When I'm done here, I have -2 over 8. Notice when I'm adding two numbers with different signs, I subtract and take the sign of the higher number. But now it's time for me to reduce. What number can I divide the numerator and denominator by? I know you're shouting 2, 2, 2. So I end up with -1/4. Is that all right? Let's take a look at a few more examples. We have about 5 examples, so yeah, 5 or 6, so stay with us. Here's example 2, adding mixed numbers. So whenever I have a mixed number situation like this one, 2 3/8 plus 3 7/8, I'm appreciative of the fact that I have a common denominator. I'm going to add the whole numbers together. So 2 plus 3 is going to give me 5. And I'm going to take care of the rest. 3 plus 7 is going to give me 10. And then I have 5 plus 8 goes into 10 one whole time with 2 left over. So that's 2 over 8. Are you guys walking with me? I hope so. So this is 6 2/8. We saw in the last problem that 2/8 reduced nicely to 1/4. So my final answer is 6 1/4. All right, so when the signs are the same and I'm adding two mixed numbers, I'm just going to add the whole number portions. Then I'm going to go ahead and add the fractional number portions. And if somehow I get another whole number out of that, I'm going to take that out and simplify as best as possible. Let's look at example 3. So here in example 3, we're going to subtract some fractions. So I've got 3 over 10 minus 9 over 10. Now the rules for adding and subtracting fractions are pretty much the same, in that you need to make sure that you have common denominators, and we do. This whole section is about common denominators. So we have 3 minus 9 at the top, and 3 minus 9 is going to give me a -6 over 10. I'm going to reduce that, dividing both numerator and denominator by 2, and I get -3 over 5. And that, my friends, is the answer. Let's look at our next example. When you heard 4 or 5 or 6 examples, you got nervous, but now we're moving so quickly you're excited. All right, let's look at example 4. We're going to subtract mixed numbers with regrouping. All right, so we're evaluating x minus y, and we're told that x is 3 1/4 and y is 1 3/4. So there's a couple ways to do this. The text is talking about regrouping. One way that I like to do it that's kind of surefire is make both of these bad boy improper fractions and then party on like we did the last time. You're just going to take the numerator, subtract them, leave the denominator the same, and then simplify with whatever result you have. However, we're going to do it the way the text is suggesting here. You can't see that wiggly line. The way this text is suggesting here, by regrouping. So here's what we do. I'm from the old school. So when I was growing up, when I was a young lad, all right, we would write it like this. over top of one another, and it gives me a little bit more space to expand and see what I'm doing. So I'm going to do it this way. So when I'm regrouping, I like to write it like this, and I like to say, okay, I cannot subtract 3/4 from 1/4. I can't take 3/4 from 1/4. So what I'm going to do is do some borrowing. So I go next door to my friend and I say, 3, can I borrow some from you? Yes, you can borrow a whole from me. So I'm going to rewrite this as 2 4/4 because 2 4/4 is 3. Keep walking with me, and then I'm going to deal with the 1/4 in a minute. So everything so far is just the same. Are you with me? 2 1/4, I'm sorry, 3 1/4 is the same as 2 4/4 and 1/4. I know that seems crazy, and I can put some plus signs here, but watch what I'm going to do. So the next thing I'm going to do is now write this as 2 5/4. Notice I have empowered my fraction to be bigger to deal with the larger fraction at the bottom. So now I'm going to subtract. I've done that, and I'm left with 1 2/4 as my answer. Of course, I can reduce that 1 2/4 to 1 1/2. Are you guys with me? I hope so. All right, let's keep pressing on. So looking at example 5, we're going to subtract some mixed numbers. LaShawn has 5 1/8 yards of ribbon to border scrapbook pages. If she uses 1 7/8 yards on one page, how much ribbon is left? So obviously you can see this is a subtraction problem because they told me. It's subtraction because the situation definitely calls for some subtraction. So I've got 5 1/8 minus 1 7/8. If I'm going to regroup, I'm going to rewrite the problem so that I have 5 1/8 over, I'm sorry, that was not what I wanted to do, subtracting 1 7/8. And we can talk about regrouping. We just did it. I'm not going to do this by regrouping first. Let me put this in red. I'm going to do this by making everything improper fractions. So if I make this an improper fraction, it becomes 41/8. Remember, 5 times 8 is 40, plus 1 more is 41. So 41/8 minus, this is going to become 1 times 8, which is 8. Plus 7, which is going to give me 15, so I have 15/8. So when I do this, I've just got 2 pretty big fractions. I can subtract them. I know what to do. 8, sorry about that. 8 down here. 41 minus 15 is, what's that, 26? Tell me if I'm wrong. You'll tell me. So I get 26/8. I can certainly reduce that. 8 goes into 26 3 whole times with a remainder of 2/8. That 2/8 keeps coming back to haunt us, doesn't it? Which we know to be 1/4. Okay, so I reduce that. Now I'm going to come back over here and do it with regrouping. And you can, honestly, you can choose which way you like. Okay, unless it says do it by regrouping, then you have to do it. But otherwise, if you're not commanded to do it a certain way, you can do what you like. So again, we're going to borrow a whole to bolster this 1/8 fraction to make it a little bit more readily available to subtract 7/8 from. So I'm going to get 4, and so the 1 that I've taken from the 4 is 8/8. If I add 8/8 to 1/8, I'm going to get 9/8. You see that? Sit down, look at it, take care of yourself. Look at it. All right, hopefully that made sense, my friends. All right, so I get 1 7/8 here. Now I have the power to subtract 2/8, 3, and then you end up with 3 1/4. Honestly, you can choose which one you like the best, unless you're obviously asked to do it a particular way to demonstrate your ability. Is that all right? I hope so. Let's go ahead and take a look at example 6. This truthfully is the last example. So we are going to write in simplest form this expression. I have 2a/10 plus 4a/10. Don't be afraid. The fact is these are 2 fractions with common denominators, so I'm just going to bring the 2 numerators together over top that common denominator. And if I got 2 A's, then I got 4 A's, then altogether I must have, don't say 8 A's, people, because we're adding. I've got 6 A's. That's right. And so at this point, I could stop here, but when I look at 6 times a/10, I recognize that the numerator and denominator have a common factor of 2. So this 6a becomes 3a because I can divide out 2 from the 6. And what I do to the top, I've got to do to the bottom. So I'm going to divide out 2 from the denominator and get 5. So my final answer here is 3a/5. All right. I hope that this made sense. I know some of you are like so over fractions that you can handle this with your eyes closed, and some of you always hated fractions, and so you're like, I hate this. However, take your time. Make sure you feel confident about the fact that when the denominators are the same, you're really just dealing for the most part with the numerators, all right? I can't wait to talk to you. Let me know if I can help you in any way, and I will see you in class. Bye-bye.